All right, guys, so for Unit 9, we have conic sections, which is looking at graphs other than lines and parabolas. Parabola is what is one of the considered conics, but it's something that we've already worked with, so that's what we're starting with, parabolas. Circles are also considered conics because you can graph circles. And then we have what is called an ellipse and a hyperbola. Okay, so we're going to learn two new types of graphs, but we're going to be starting with circles and parabolas because that's what we already know about. Okay, so a parabola is an equation of the form y equals ax squared plus bx plus c. Okay, so that's something we already know. It has to have an x squared in it, and the a cannot be equal to what? Do you guys know? 0. It can be equal to 1, but we can't have a equal to 0, which means the x squared has to be there. Okay, so now we did talk about, there is a descriptive or vertex form. We've already talked about this when we did parabolas. That was y equals a times x minus h, all of that squared, plus k. Remember that? And remember, there's something special about that negative h. The graph is the opposite of that because of the negative sign. So that was vertex form, in which we didn't have to do any work to graph it. And then we have some definitions. Remember, vertex. Vertex is that point on the parabola where everything starts to become symmetrical, so it's the minimum or the maximum. To find the x-coordinate, we plug in negative b over 2a. Let's actually put a box around that. Okay, so to find the x-coordinate, we plug in negative b or 2a, and then to find the y, we plug x back into the equation and solve. This should be review, right? Sound familiar, at least? Okay. We also remember what's called the line of symmetry. The line of symmetry is an x-coordinate only, so it's the x-coordinate of the vertex, and it gives you the value of the axis of symmetry. Does the line of symmetry go up and down or side to side? It can be either one, but we've only worked with up and down so far, right? Remember, this is an equation, should be x equals negative b over 2a. Okay, so to find the line of symmetry, we plug in negative b over 2a. That's the x-coordinate. And then we also talked about the way it opens. A graph opens upward, which means it's going this way. If a is greater than 0, which means it has a minimum value. And the minimum is always the y. So line of symmetry is the x-coordinate. Min or max is the y-coordinate. And then it opens down if a is less than 0, which means a is negative. And then it has a maximum value. I know I'm going kind of fast. Okay, so I have a table for us to just kind of fill everything in to put all of our information together, so let's fill it out. We have the form of an equation, y equals a times x minus h squared plus k. This is in vertex form, so why don't we label that vertex form? Okay, and remember, we like vertex form because it gives us our all of our information. The line of symmetry is x equals, the x-coordinate is that h right there. So x is equal to h, or the opposite of h, right? The vertex, the center, your x-coordinate is h, which means your y-coordinate is k. When is the parabola opening up? If a is positive or greater than 0. And it's opening down if a is negative or less than 0. So all of our information is just in this chart. Okay, so I gave you all the definitions, and now we can use the chart to kind of get all of our information.
So what do we...
I gave you the very first one on the first page is just a graph where everything is in general terms. My vertex is h comma k. So for all intensive purposes, let's just say it's at 0, 0 right now. is A is going to be my parabola. In this case, A is positive, so it's just going to be opening up. So this is just an illustration of what a parabola looks like, which we already know. Okay, so this is just general terms. Okay. So in this case, my line of symmetry would be going through the middle. Okay, but let's actually do a problem. So, example 1, we have y equals x minus 3 squared plus 4. So, let's look. This is in vertex or standard form? Vertex form, right? So, this is really nice because we don't have to really do much work. What's my vertex? 3. Because remember, even though there's a negative attached to it, we take the opposite. So 3 and the y-coordinate is 4. So let's graph that first. 1, 2, 3. 1, 2, 3, 4. Okay. The LOS, the line of symmetry, is the x-coordinate. So LOS is going to be x equals 3. So let's draw our line of symmetry. All the way through. And does this one open up or down? It opens up because what's actually in front of the parentheses that we can't see? A positive 1. Okay, so this one's going to be opening upward. So let's just sketch it. Right now we're just sketching. So and this one opens up. So it doesn't really matter how wide it is right now. Okay. You guys okay with that so far? Okay, let's look at example 2. Example 2, is this one in vertex or standard form? This one's in standard, so we actually have to do a little bit of work. How do I find the x-coordinate of the vertex? So A is what? 1. B is 8. And C is 13. So let's find the x-coordinate. That is x equals negative b, so negative 8 over 2a. So x equals negative 8 over 2. So x equals negative 4. So my vertex, my x-coordinate is negative 4. How do I solve for y? Plug it back in. So that's going to be y equals negative 4 squared plus 8 times negative 4 plus 13. Negative 4 squared is 16. 8 times negative 4? Negative 32 plus 13. Which gives me 6 minus 32 plus 13. All that gives me negative 3. So my y-coordinate is negative 3. So let's graph that first. 1, 2, 3, 4. 1, 2, 3. Line of symmetry is x equals what? Negative 4. You get the LOS just from the x-coordinate. And does this one open up or down? This one is also opening up because A is positive. So we're just going to sketch it. Make sure it's symmetrical around the line of symmetry. It's opening upwards. So I want you guys to try 3 and 4 by yourself. Looking at number 3, is this one standard or vertex? It's actually standard. It could be vertex too, but let's think about it. If I have negative 3x squared, what's the b term? Same as 0x, right? What's the c term? Also 0. So A is negative 3, B is 0, C is 0. They're not there, so we can just assume they're 0. So, so use those A, B, and C to do example 3. Example 4 is very, very similar. Okay, so using A equals -3, B is 0, C is 0, what did you get for the vertex? Okay, so because A was -3, B is 0, C is 0, my x-coordinate was 0. When I plugged x back in, I got 0 for y. That's my vertex. Line of symmetry is the x-coordinate, so I drew it straight through, and it's opening down because A was negative. So that's what my graph should look like. Good? Okay. Okay, what about the number 4, last one? In this case, A was what? 1. B was 6, and C was not there, so it was 0. So it's the same thing as writing +0 at the end. So when you plugged A into -b over 2A, what did you get for x? -3. And when you plug -3 all the way back in, what did you get for y? -9. Good. Okay, so we should graph that one. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. So all the way down here at the bottom. So if that's my vertex, line of symmetry is what? X equals -3. So let's draw that. And this one's opening up or down? Up. So my graph should look something like that. As long as it's symmetrical right now, we're just sketching. So we're not worried about wide or narrow yet. Okay?
Wait, that was right.